Welcome to The Explainer. Today we're embarking on an incredibly deep synthesis of neurobiology, computational models, and contemplative science. Look, if you study the mind, whether you're a neuroscientist mapping the brain, a philosopher, or an expert meditator logging thousands of hours on the cushion, you already know the ultimate frontier. It's bridging the subjective experience of consciousness with the objective measurements of the brain. In this explainer, we're going to rigorously examine how ancient Indo-Buddhist and Taoist traditions function, not as mere mysticism, but as highly calibrated instruments of observation that can intimately inform our modern computational theories of the brain. Let's get right into it.
Okay, let's dive into this. At the very core of our inquiry is the infamous hard problem of consciousness. We're constantly searching for the absolute minimal neural conditions under which subjective experience arises. Specifically, we want to isolate the neurocorrelates of minimal phenomenal experience, or MPE. But doing that, it requires peeling away the rich, complex layers of everyday thought and sensory input just to see what fundamentally remains underneath.
To do this, we'll follow a precise roadmap today. First, the measurement problem. Second, the epistemology of the mind. Then, technologies of non-dual awareness. Fourth, bridging the calibration void. And finally, deep computational neurophenomenology.
Starting with Section 1, the measurement problem, the hard problem. Right now, we're facing a real crisis in cognitive science because despite decades of highly advanced neuroimaging, isolating the exact physical substrate of our conscious experience, it remains completely stalled.
There's a massive dialectical tension here. On one side, you have the dominant assumption of Western neurobiology, that consciousness is an emergent property generated by the physical matter of the brain. And on the exact inverse side, you have Eastern non-dualism, like Advaita Vedanta and Dzogchen. These traditions posit that pure non-dual consciousness is actually the fundamental ontic substrate of reality itself.
Western science attempts to formalize this philosophically through Giulio Tononi's Integrated Information Theory, or IIT. IIT approaches consciousness as a fundamental property of systems with irreducible cause-effect power, quantified by a mathematical measure called phi. In this framework, if a system integrates information in a way that makes a difference to itself intrinsically, well, it's conscious. Much like mass bends spacetime, IIT suggests consciousness is inextricably linked to certain physical architectures.
Now, competing with IIT is the global neuronal workspace theory, which is fundamentally different. GNWT focuses on access consciousness, the idea that information becomes conscious when it's globally broadcast across the brain's networks. Recently, the massive million-dollar Cognited Consortium ran an adversarial collaboration testing these two theories against each other. And the result? While it yielded some fascinating empirical data, it ironically left scientists scratching their heads regarding the ultimate nature of consciousness itself. The behavioral and physical measurements simply aren't enough on their own.
Which brings us to a recent, incredibly compelling paper by Lieberman and Sackett. They outline a minimal model framework, leveraging advanced meditation. They argue that by studying practitioners who can access states like profound concentrative absorption, jhāna, and even cessation events, nirodha, we can strip away all that typical perceptual and cognitive clutter. These meditative states act as precise, replicable phenomenological anchors, giving us a way to study consciousness in its most reduced, fundamental form.
This naturally leads us into Section 2, epistemology of the mind and observing consciousness. To actually utilize these states scientifically, we really have to understand how Eastern traditions have historically approached the mind as a rigorous empirical science.
In Indian epistemology known as pramanavada, observation is highly formalized. A cognitive act involves the pramata, the knower, the prameya, the object, the pramana, the instrument of knowing, and the prama, the resulting valid cognition. This is a brilliantly granular mechanics of non-conceptual direct perception. It treats contemplative practice not as some mystical leap of faith, but as the systematic refinement of an observational instrument, the mind itself.
We see this most vividly in Yogacara Buddhism. Yogacara developed a dynamic, eightfold architecture of consciousness, culminating in the ālaya-vijñāna, or storehouse consciousness. This was designed to deconstruct the illusion of a separate perceiving subject and an external object. So the crucial point is that their famous mind-only doctrine isn't a metaphysical denial of physical matter. Rather, it's a strict epistemological boundary. It asserts that all possible experience is inescapably contained within the structures of consciousness.
Moving right along to Section 3, technologies of non-dual awareness, contemplative tech. How exactly do we calibrate the mind to observe these deep structures? Well, we use highly specific somatic phenomenological techniques.
Consider the classical Taoist practice of zhuang,
or sitting in forgetfulness. Unlike concentrative meditations where you focus intensely on an object, Zhuang operates through radical subtraction. It's a precise technology of non-striving, deliberately dismissing sensory faculties and conceptual knowledge to merge with a natural state of choiceless awareness. And this perfectly mirrors the Indian yogic concept of chitta vritti nirodha, the complete cessation of mental fluctuations.
Then we have the Tibetan tradition of Dzogchen, which offers an extraordinarily advanced phenomenological cartography. Dzogchen makes a vital distinction between SEMS, the ordinary grasping discursive mind, and Rigpa, which is primordial, self-luminous, non-conceptual awareness. The practice shifts the practitioner's focus entirely away from the contents of consciousness and directly onto the how of consciousness. This is an absolutely vital distinction if you're trying to isolate true minimal experience in a lab setting.
And as we noted earlier with our minimal model, advanced meditative endpoints like jhana and nirodha push this to the absolute limit. They temporarily suspend typical consciousness to reveal its underlying skeletal structure, a structure completely invisible to the ordinary, untrained, introspecting mind. And surprisingly, these aren't just fleeting, random occurrences. Expert practitioners often log upwards of 10,000 hours of rigorous practice to reliably replicate these specific phenomenological anchors.
This brings us to Section 4. Bridging the calibration void, validating introspection. This is where we directly answer the scientific skepticism regarding subjective self-reporting.
Skeptics correctly point out that naive introspection is highly unreliable. But think about it this way. Just as a scientist must undergo rigorous training to interpret visual data from an electron microscope without introducing subjective artifacts, a contemplative practitioner must undergo systematic mental training to stabilize, refine, and calibrate the mind as an observational instrument. You wouldn't trust an untrained person to interpret abstract microscope outputs, right? Similarly, you cannot trust an untrained mind to observe the mechanisms of its own consciousness. Contemplative practice systematically trains the mind to overcome this calibration void, transmuting it into a valid scientific instrument.
This precise calibration is the absolute engine of neurophenomenology. This was a groundbreaking research program initiated by Francisco Varela. Varela argued that neither the biological third-person data nor the experiential first-person data should be reduced to the other. Instead, they have to relate through what he called mutual constraints, where brain data and subjective experience actively inform and validate one another.
Let's see how this builds into an actual experimental method. It happens in 3 strict stages. First, phenomenological training to stabilize the observer. Second, high-resolution neural measurement during these specific stable states. And third, mutual constraint. We now have solid evidence that this willed attention and deliberate practice actually causally reshapes the neural infrastructure, proving a bidirectional interaction between consciousness and matter.
Which brings us to our final synthesis in Section 5, Deep Computational Neurophenomenology, Computational Synthesis. This is the exact moment where ancient epistemology meets modern computational modeling.
Enter Carl Friston's free energy principle and active inference. This posits the Bayesian brain, a hierarchical generative organ constantly trying to minimize variational free energy, or surprise, by predicting sensory inputs. Meditation in this context alters the precision weighting of these prediction errors. And this brilliantly illustrates how the brain dynamically updates its internal recognition density across statistical boundaries known as Markov blankets. In this framework, consciousness isn't a static thing. It emerges from a dynamic process of self-modeling.
When we align these modern computational mechanisms with ancient liberation paths, the structural parallels are just undeniable. Look at the alignment here. Whether it's IIT looking at a maximally irreducible complex, active inference modeling the self to minimize free energy, Yogacara Buddhism detailing the seventh consciousness grasping the storehouse, or Advaita Vedanta describing the reflection of absolute light, they are literally all charting the exact same multidimensional architecture of how localized selfhood emerges and fundamentally how it can be transcended or resolved.
By uniting these, deep computational neurophenomenology leverages what's called dual information geometry. It establishes a direct generative passage between the lived, non-dual experience reported by advanced meditators and the physiological, parametric instantiations recorded by neuroscientists. It's a meta-Bayesian framework that successfully bridges the physical and the phenomenal by literally incorporating trained reflective awareness into the math itself.
Which leaves us with a truly profound implication. If we can map the exact computational mechanics of how the brain minimizes free energy to construct a self, and we understand the specific contemplative algorithms required to deconstruct that self into pure non-dual awareness, could integrating Bayesian mechanics with ancient non-dual realization be the key to designing artificial systems that don't just simulate intelligent behavior, but actually genuinely embody consciousness? I'll leave you to ponder that. Thank you for joining me in this explainer.